Okay, so for this new series of videos, we will investigate the use of arrays to store data. And what's going to be interesting with arrays is that the data will be stored in consecutive memory locations. Okay, so if you have to store five numbers of the same type, five integers or five floats, and you want to organize them in a manner in which they will be stored next to each other in memory, then the array will be your best choice as a data structure. And the reason behind it is then you can manipulate the array to change values within it or navigate the array using either an index or a pointer. Okay, so that will be the way we're going to access these arrays in subsequent videos or lessons ahead of us. But first, what we're going to do right now is introduce you to the basic concept of an array, how to declare it, and how to basically access it, and what does it mean vis-a-vis memory. So let's get started. So let's say I wanted to store five integers next to each other. Okay, so if memory is important and where you store them is important, an array will be the way to go. If you didn't, then something like this would have worked. Int A, comma, B, C, D, E, right? So this will be your variables, right? But these will be scattered, or they're not necessarily going to be next to each other in terms of how they're going to be allocated into memory. Okay? There is a better way. So what would that be? So let's do this. Let's call it my array. And notice now the syntax. You're going to put a bracket, and I'm going to put 5 in there. So I'm going to have 5 elements. So this is an array of 5 integers stored next to each other. And we're going to prove this. So let me compile this for now, just to make sure that it's working just fine. Perfect. So what we're going to do now is look at the actual memory locations for each one. Now notice this 5 here means that is the size. Could we have declared it in a different way? But for example, could we have done something like this? Int size, and let's say we say that one is equal to 20, and declare another array, int my other array, and then put size here as a variable. The answer is yes, as long as you do this ahead of time. Okay? Arrays are not dynamic data structures. They're fixed. Once you've set the size of an array, you're not going to be able to change it again. So let's compile this for a minute here. Let's compile this. Okay? And you're not going to be able to access beyond whatever size you have. Now, how do we access the data members of this array? There are 5 data members here, or if you want this one, there are 20 data members in here. Here I've shown you a couple ways to define the size. So you could do it right here, or you could do it this way. Now there are other ways to define size as well. Okay. Let's say now I want to know for my array right here, for this array here, how memory is used. Okay. So what we're going to do is cout, and we're going to look at the memory locations for each one. And the first one, and percent, my array, and the first data member is going to be 0. So 0 now is what we call an index right here. So this here, when you declare it, it's basically defining the size of the array. When you're using it, it becomes an index. Okay? So let's do this, /n. And what we're going to do now is look at the next one. And we're going to do and percent myArray 1. And then give me a new line. And we're going to repeat this. So I'm going to repeat this a total of 5 times, right? So I need 3 more times here. Copy. 2, 3. Put a semicolon here. And what we're going to do is change this index to 2, this index to 3, and this index to 4. And that's it. You're going from 0 to 4. That's 5 count. Now let's go ahead and compile and run and see what these addresses, how these addresses look like. And there they are. Okay? So notice the first one is 22FF20. Now we know that each integer will take 4 bytes, right? And let's see if we're actually moving up 4 bytes at a time. And sure enough, the next item is 4 bytes downstream, another 4 bytes downstream, another 4 byte. And remember, this is hex. C is a 12 in decimal. So from 8 to 12 is 4 bytes. And then notice here, from 12 to 16, notice now 0 to 0, 1, 0 is 16. So the 1 got carried over here. This is why the address here increased by 1. Okay, so that's counting in hexadecimal, right? So if you added 4 byte to 2C, you end up at 30. Okay, so what it's telling me is that I have all these memory spaces reserved for my array, and they're spaced out by 4 bytes. Excellent. Can we put data in them? Answer is absolutely. So can we do something like this? My array. Now remember, before I put an %, so I was interested in the address. Now I am interested in the actual member of the array to store something in it. And I'm going to store a number here, equals 99. And I'm going to go ahead and do my array at 1 equals 78. And then I'm going to go ahead and do my array at 2 equals -9. Okay? And then I'm going to go ahead and do my array. So now you're doing what we call an assignment. You're assigning an integer value to each member of the array. And we're going to put a 0 on this one. Okay? You're going to put any integer you want, as long as you're using the indices from 0 to 4, right? So you're within the scope of this array. Or should I say the size of this array? So this would be 4. You could randomly assign. You could start with 0, then 3, then 4. I'm just keeping it organized, okay? So I'm going to put 100 here. Now, can we display what's in the array? Okay, so first, this here shows cout, memory, allocated for the array, my array. And that would be the notation for that. You just put a /n here and do a semicolon. So that's going to show that. Now what we're going to look at is the content. So cout, content of my array. We're not going to do any loops or anything fancy. Just right now we're going to access them directly. In the next video, we're going to use a loop to access these members of this array. So, cout. And this time, let me go ahead and do something like this. My array 0 equals, so we know that's the data that will be stored there. And that would be my array 0. So we're going to match it. Okay. And then what we're going to do is put a /n here, give me a new line. Okay. And go back and do the next one. So what I'm going to do is copy this right here and repeat that another 4 times. So I'm going to go over here, man v. So that's 1, 2, 3, 4. So change now the indices to match. So 1, and we're going to have a 1 here. We're going to do a 2 here. So at index 2, and at index 2 here, index 3, and index 3, and then with index 4, and then with index 4, and I'm going to put a semicolon here, and let's look at how this would look. So go ahead and compile and run, and there you have it. So what do we have? We have these consecutive addresses, and in each address we have an actual integer stored in there. 99 will be at starting at address 20. 78 will be at address 24. -9 will be at address 28. 0 will be stored in 2C. It will take 4 bytes to store it. And 100 is stored at 22FF30.